I'm super excited because today I'm going to talk to you about how to make your own homemade pH indicator. Of course, this depends on having permission of a guardian in your home and taking the safety precautions that I'm going to talk about. But this can be a really excellent way to get to visualize a pH indicator at home. If you can't, for whatever reason, I'm going to do it on video too, so don't worry. So our learning goals for today are to make a homemade pH indicator with purple cabbage, or you can watch me make it. We will use that cabbage juice indicator to determine the pH of several household substances. And finally, as some practice to relate it back to the indicators that are more commonly used in chemistry labs, we will use the information from Table M to determine the pH of several substances given their reaction in the indicator solutions that we'll read about on Table M. Let's go. Please note that you should not be doing this activity at home for any school assignment unless you have filled out a safety contract for conducting remote hands-on and laboratory activities involving the use of hazardous materials and tools at home. Specifically, you'll want to make sure that you and your parent or guardian has read and signed the description of this activity, which I will read for you now, and reviewed the other qualifications of the contract. So the activity is going to involve preparing cabbage juice pH indicator. The cabbage must be roughly ripped into small pieces, then boiled on the stove for approximately 5 minutes. The cabbage juice should be left to cool for at least 30 minutes, then the liquid should be strained into a jar or lidded container. The leaves can be disposed of. The cabbage juice indicator can now be used as a pH indicator. Students should gather household substances that are slightly acidic or alkaline, basic, including lemon, lime, or orange juice, clear soda or seltzer, dish soap, hand soap, shampoo, other cosmetics, tap water, and any other substances that are considered safe, commonly used household liquids in your home. Please do not use strong cleaning agents such as ammonia, bleach, or drain cleaner. So you will be using a stove to heat the water in the cabbage, and a variety of household mixtures that you suspect or that you know may have a pH that is not neutral. And a knife is not necessary, but may be used to chop the cabbage. Please make sure you have reviewed the entire safety contract and returned it to your teacher before you are participating in any of these activities for school. Whether you're doing this at home or just watching my video, I'm going to start preparing my cabbage pH indicator. So I am chopping my cabbage. You can also rip it with your hands into pieces. And they don't need to be any particular size. They just need to be small enough that I've increased their surface area so that more of the surface of the cabbage can interact with the water. Then I'm going to use about a cup, 2 cups of water, and this was 3 cabbage leaves. And I am going to monitor the stove as I bring it to a boil, and I let it boil for about 5 minutes. After 5 minutes have passed, and I clearly have my time sped up here as you're watching me cooking show style. After 5 minutes have passed, I'm going to turn the stove off and then give the whole mixture about 30 minutes to cool so that I can make sure that I'm not going to burn myself when I go to retrieve the cabbage juice. Once 30 minutes have passed and I am ready to retrieve my cabbage juice, and I'm sure that it's cool, I'm going to get a strainer and I'm going to get a bigger bowl. I'm putting the strainer inside the bowl so that I can catch the cabbage leaves and get rid of them, but I want to hang on to the liquid that I just strained out. So the cabbage leaves I can put aside to compost or throw in the trash, and the cabbage juice I'm going to transfer to a small jar so that I can then, I'm using a funnel here so that I don't make a mess. And you'll see that this is a very dark colored cabbage juice indicator. I probably want to dilute it with water before I start adding it to other substances, but my indicator is now ready to go. So you might have a different set of substances available to you, but I will be testing vinegar, lemon lime seltzer, hand soap mixed with water, tap water, baking soda, and I'm going to also test some lye, which is an ingredient in drain cleaner. As I said before, if you are doing this at home, you should not use that particular substance as one of your tests because it can be hazardous if it gets into contact with your skin, but I will use it just as a demonstration here in this video. You can also use other household items that can be dissolved into water and be a liquid. And you don't need to have test tubes to test your cabbage juice indicator, right? You can just have some clear glass that you can see inside of. So I'm going to add a few drops of vinegar to my cabbage juice, right? All I've got in the test tubes right now is cabbage juice. And now I'm going to add a few drops of lemon lime seltzer. I can already see some color changes happening. Going to add some hand soap. I will add some more tap water to my tap water tube, just to make sure it's not going to change away from that purple color that it already was. I will add a baking soda solution, so baking soda dissolved in water. There's a pretty dramatic color change. And then finally, again, some of this lye, which contains sodium or potassium hydroxide, depending. And again, we get a pretty dramatic color change there. So let's think about what's in the cabbage juice that's actually causing this to happen. It's really pretty cool. So this is a really excellent infographic that again summarizes how we went about making the indicator solution and also talks about the color scale that we can use to determine the pH of our substances after we have gone ahead and made our solution. So looking at my indicator solution here, if I compare that to the color of the substances that I actually end up with, I can sort of estimate the range of pHs for the different substances. Why don't you take a moment to pause the video, look at the pH scale on the infographic, and look at my image of all of my samples, and let's try and come to a consensus on what we think a good estimate of the pHs might be. So pause the video, unpause when you're ready. This is an estimate since it's qualitative, but I'll talk through what I'm thinking. The vinegar seems to have a pH of between 2 and 3, kind of that light dark pink into a light pink, maybe between 2 and 3. The lemon lime seltzer seems to be more around 4. The hand soap more around maybe between 5 and 6. The tap water seems to be between 6, 7, and 8, probably more around between 6 and 7. The baking soda solution looks like it's about 9. And the baking soda solution looks like it's between a pH of 10 and 11, if I'm trying to match to my colors here. Do you agree? As long as you have permission to use a substance and it is not hazardous in any way, you can ask a parent or guardian if there are other things in your household that you can test if you've tried out this indicator solution yourself at home. The reason this happens is that there are these different molecules in the red cabbage extract, that's the liquid that's come out of the red cabbage, that change their structures. Specifically, they're called Anthocyanin Pigments, and they change their structures very slightly, which leads to a color change based on the way the light hits the molecules and then reflects back to our eyes as the concentration of hydrogen ions changes. So if you look very closely at each of the chemical structures under red, violet, blue, and yellow, green, you can see that they all have slightly different ion situations going on because they are all impacted by pH. Let's do a quick practice problem. What is the color of Bromkressel green indicator in a solution with a pH value of 2.0? Take a moment to study table M. I'm going to give you 30 seconds. Pause the video if you need more time. So since Bromkressel green indicator turns from yellow to blue, it's yellow if the pH is less than 3.8. It turns green if the pH is between 3.8 and 5.4. And it turns blue if the pH is above 5.4. Since this pH is below 3.8, the indicator will still be yellow. It doesn't start to change colors green to blue until the pH reaches 3.8, and 2.0 is less than that. One more question. A sample of normal rainwater has a pH of 5.6. State the color of methyl orange in a sample of this normal rainwater. So if the pH is 5.6, methyl orange turns from red to yellow at a pH of 3.1 to 4.4. So if the pH is 5.6, that is above 4.4, so the indicator will have turned yellow. All right, let's check back in on our learning goals before we go. If you have extra cabbage lying around, I suggest making a nice salad with it. You can chop it up real nice, put it with some dressing, it's really good. The cabbage juice you're probably going to want to throw away. It's not going to be so good. Let's make sure that you feel comfortable using pH indicators before we go, right? Thinking about using table M to determine what the pH of a substance is, knowing what color it turns in different color solutions. Awesome job today.